high school chemistry teachers. I'm Kendra, creator of ChemEd Solutions, and it's my mission to change the narrative of high school chemistry from yuck to yay by designing student and teacher materials that allow you to focus on what matters most, getting all your students to be confident and successful without the burden of using your personal time to do so. I support you by giving you my best proven tips vetted by thousands of students, parents, and case managers. So today's tip comes from our unit on bonding, focusing on Lewis structures. Lewis structures is something traditionally taught by drawing valence electrons around our atoms and then drawing circles connecting them to create bonds. However, if a student is just the slightest bit unorganized or untidy, it can go sideways really quickly. So this is a better way to teach Lewis structures. It still has 4 steps, and with that, I found that students, if they follow these 4 steps, always get the correctly drawn Lewis structure. Important is that students either are able to rewrite things if they're going to use pen, or I very much encourage them to use pencil. So first we have them count valence electrons. Then after that, they're going to make their skeleton of the molecule, putting most electronegative element in the center, but we know that carbon will go in the center if it can. Then we start at the central atom. We count the number of electrons it has access to in the bonds, and then we complete octets. So starting with the central atom, adding lone pairs of electrons where we need to, then moving to our outer atoms. From there, we count up our total electrons drawn to see if the number that we have drawn matches the number of valence electrons available to us. If we have drawn too many electrons, that means that we know that there are not just a bunch of lone pairs of electrons. However, electrons are really shared in bonds, and we need to turn some single bonds into double bonds. To do that, we take a pair, and make them share, and I'll show you that here in a second. If there's too few electrons, then we're going to add pairs to the central atom. However, this is just for expanded octet molecules. More than likely, in regular chemistry class, you're not getting to this point. It's more for if you have an honors class or an AP prep class. But I put this here because this is a factor when we do it this way. So let's go through an example together. If I have ammonia, NH3, I start by counting my valence electrons. I have 1 nitrogen. Each one gives me 5 valence electrons. That has 5. I have 3 hydrogen. Each one provides 1 valence electron, so 3. Total valence electrons that I have access to is 8. Then I go ahead and I draw my skeleton, nitrogen in the middle, with my 3 hydrogens branching out, so these electrons aren't drawn yet. Then I go ahead and I count my electrons and fill octets. So nitrogen currently here has access to 2, 4, 6. It wants 8, so I add my lone pair of electrons to my nitrogen. And then each hydrogen wants 2 valence electrons. So it has 2 here, 2 here, and 2 here. So I've drawn my skeleton. I filled octets, and now I'm going to count to see if what I have drawn matches up how many valence electrons I actually have to play with. So counting 2, 4, 6, 8, which is how many I have, so my molecule is drawn correctly. Well, what if I've used too many electrons? Let's go over that example. So if I have sulfur dioxide, I have 1 sulfur. Each one gives me 6 valence electrons, so that's 6. I have 2 oxygens, each one providing 6 valence electrons, so that gives me 12. Added together, I have 18 total to play with. So when I first go ahead and I draw my skeleton, I put my sulfur in the middle, a bond out to oxygen, and a bond out to oxygen. Then I fill my octets, starting with the central atom. So sulfur has access to 2, 4, it wants 8, so I add 2 more at the top, 2 more at the bottom. And then each oxygen has access to 2 in the bond, so I need to add 6 more, 2, 4, 6, 2, 4, 6. Now that I've drawn my full skeleton and I filled everybody's octets, I look to see and count up, does this match how many valence electrons I have to play with, or do I have to take some and really make double and triple bonds? So I count up 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 electrons. Well, I only have 18 electrons to play with, so this is drawn incorrectly, which means I have too many electrons. So I'm going to take a pair for my outer, take a pair for my central, and make them share. Take a pair, make them share. So in reality, instead of a single bond here, I have a double bond here. So here's my double bond. So then these electrons go away because I really don't have two pairs. I really have two electrons being shared in a bond instead of 4 electrons. And then I count my electrons again. So I draw everything else. If I was using pencil, I just have them erase these and draw my line here. So I count 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons represented here, which is how many there's actually available in my molecule. So that means that I have drawn it correctly. To never miss a weekly teacher toolkit tip and get access to a PDF copy of both the teacher and student versions of this, sign up for my email newsletter at www.chemedsolutions.com/chemguide. In addition to weekly teacher toolkits tips, when you sign up, I have a few gifts just for you, including a high school chemistry course outline, a pacing guide, a unit checklist that you can use for every unit that you plan, and my personal teacher planner to keep yourself organized, less stressed, and enjoying life. And again, the link for that is below this video in the notes. And with all of that, happy sciencing.